Hi, I'm Gina Saganek. I'm the CEO of a nonprofit called the Healthy Building Network, and we do research and education mostly around the toxic chemicals in building products and how they impact. So this has been a phenomenal morning so far, listening to all your research. It's pretty incredible. Before I went to Healthy Building Network, which was about 3 years ago, I spent the first 20 years of my career developing affordable housing for marginalized communities. So I'm a warrior for health equity and trying to really figure out how all of this applies. So I'm not a chemist. I always say I'm more of a chief translator of the amazing chemists, and how does this information translate? So, and how can it be applied? So what I'm really curious to hear from you all and the rest of the presenters today is, are you doing any research in how people who are living in areas where there are factories and the air is more polluted than maybe some of the research homes, and where they're living in often communities with more dilapidated housing, they're in multifamily housing where you not only have impacts from who's ever coming in with deodorant, but all your neighbors who have deodorant. And people who are working in the factory all day and bringing home pollutants and just their exposure. So I know you all know very well that the marginalized communities, people of color, low-income populations, kids are much more exposed. So I'm super curious to hear how some of your research is maybe looking at that side of the equation and what we can do in those communities to make sure that those groups aren't facing the health consequences, who often don't have health insurance on top of that. So I appreciate that. Thank you.
Go for it.
Yeah. Okay. Is this on? Yes. Well, thank you so much for bringing that up. Those are incredibly important topics, especially if you think about the U.S. building stock. There are so many different types of homes, and I know there are a lot of, I haven't done any of that research myself, but I know there is a body of knowledge on linking the leakiness of homes with their age and whether or not energy retrofits have been applied, especially in low-income housing. There's a lot of research there, but questions still remain on the effectiveness of these energy retrofits in making the house more airtight versus leaky, and that's about your point of outdoor air pollution infiltrating in. There are some studies as well on the effects of building insulation. There are many low-income housing units that have missing spots of building insulation. This reminds me of research from Dr. Getty Manelis from Rutgers University. He looked at homes, buildings in the state of New York, and they were looking at New York, New Jersey, and they were looking at potential penetration of outdoor air pollutants just through these areas where the insulation is missing. So there's a lot of research on that, but I don't think there's a general consensus. When it comes to indoor sources, the same applies. We can't dictate what people do in their homes, so there's a lot of variability there in terms of indoor sources and behaviors, and I'm sure my colleagues might have something to add.
I want to add one thought. Oh, Barb, go ahead.
Just, I wanted to mention that there was a study called the REOPA study several years ago, and that it was 150 homes in each of 3 cities, and the homes were over-selected for homes particularly near outdoor sources. And so they did look at the effect of distance to source on VOC exposures and on PM, particulate matter, also we. I'm one of the PIs on that study. And I don't want to tell you what we found because it was long enough ago that I'm not going to get it right. So we can talk about it later today if you'd like.
So Great. I wanted to say one thing in response to you. Part of what you're seeing today, at least with my talk and Nina's talk, is the result of research that was funded specifically to look at chemical processes, to look at fundamentals in non-problem homes. A lot of the techniques that we're applying can be applied to other places that have problems. I actually think that one of the most interesting things to do next would be large apartment buildings where there's a lot of indoor-outdoor exchange, but there's a lot of breathing what your neighbor is cooking. And there haven't been a lot of studies with the kind of instrumentation that we've been using in that type of environment, but I think they're really critically important. And hopefully one of the things that comes out of this meeting here is some connections with organizations that have other interests. You know, Sloan's interest is in fundamental chemistry processes, but I know a lot of you are coming from a different perspective and want to support different kinds of work. And so that's why we're here to communicate.
Can I add one more point, if you don't mind? 11% of Americans now live within 100 meters of a freeway, a highway, or a really busy roadway. And the body of knowledge of health effects of people that live in close proximity to freeways is overwhelming at this point, wide range of health effects. So I think when you look at that versus people that live near major industrial facilities, there's more health data that suggests that living close to a roadway is as or more important. And so I think that's an area we need more research on.
And there's a lot of affordable housing for communities where the neighborhoods went through, so all of that.
Right.
Thank you.
Can you repeat her comment, because we can't hear her. Can you repeat it, please?
Yeah, maybe she can speak to the mic. That's a good reminder for everybody with questions.
Yeah, thank you. I just mentioned that those freeways, that's where a lot of the affordable housing is built because of the NIMBY, not in my backyard, and it's just where poor communities, that's where highways were put through. So again, that goes back to marginalized communities, the highways.
I do want to make an announcement that the people that are watching the webcast can submit questions online in the chat box or on Twitter using
Here's the hashtag. AAAS.
the hashtag on the screen.
So I think the speakers did a very good job of educating me about why total VOCs, just looking at that, is not very useful. So, you know, since I don't consider eating oranges or making toast dangerous activities, has there been progress in, you know, relatively quicker or easier ways of, you know, discerning the dangerous VOCs versus those that are not?
It's a great question. I guess people are looking towards me. And I think that the research that I showed was largely done in sort of a discovery mode, right? And we were trying to understand what's there, how's it behaving. We could use so many different filters to look at that data. One filter could be, what are the chemicals that we have health concerns about? You know, what does the health community worry about? And we are doing that as well. So there's a paper that just came out on the phthalates in the home and how they behave, which are, you know, some of the compounds that Rich talked about. But I think that it's absolutely important to look at that particular issue. However, one thing I worry about is that the health community often focuses on chemicals that they already know have health impacts. But what we're trying to do is take a really broad spectrum approach to see what is there. And I think that some of our results are pointing to chemicals that haven't been identified necessarily as having health effects, but may be important. And so we need to not just restrict ourselves to the things that the EPA already knows are a problem, right? So that's my answer.
And also, too, I think there's research, too, to start to look at the actual mechanisms of the human response. And that's really the challenge. Paula mentioned earlier about regulations. Outdoor regulations can focus on specific chemicals, but the indoor receptor is the human, and we don't know everything we need to know yet to decide which chemicals or what classes of chemicals. And I think that, you know, we're in the mixture, and so you've got to think about a lot of synergistic effects. And, you know, how oxygenated species kind of, and particles kind of react with us. So that's still coming together. So.
And as a plug for Ray, if I may, his group and some of his colleagues at NIOSH are probably one of two groups in the world when you look at reaction products where we don't have any good tox data. You know, they've been sort of leaders in trying to decipher the health effects of these reaction products, which we haven't focused much on until recently because we're identifying them at this time. So I think if you Google NIOSH and find Ray and his group, there'll be some information there about sort of prioritization of oxygenated compounds.
Right, we're trying to figure some of that out.
Thank you.
Hi. So I had a quick question to follow up kind of the first question, and also the talks we saw today primarily focused on residential environments. And I'm looking around this room, and there's probably at least 60 people in here, and we're going to be in here for 6 hours or so. So that's 360 person-hour exposure equivalent in 6 hours. And my wife and I, 2 people in a bedroom, where we spend the most of my time in my house, that would be 20 to 25 days of sleeping 8 hours a night, which doesn't happen because we have 2 kids. But so in terms of priority spaces, is the home, maybe for my personal exposure, the most important, but for an integrated people exposure, do we need to start considering other high occupancy spaces as places to do more of these focused studies as well? The question to you guys.
I'll say the home is very important. You've already seen the numbers in terms of the number of years we spend on it, but it's also where children spend most of their time. And you know, children, infants are pretty important receptors of air pollution, especially if we're talking about things like endocrine disrupting chemicals, et cetera. You're right, though. I mean, we have to study beyond the home. Schools or environments where you have your most concentrated, you know, density of people per square meter, right? And so school environments are another environment that needs to be studied, again, focusing on children. Hospitals, office places, we need to study all of those. I think we all focused on homes because we have data for homes and because homes are where we spend the largest fraction of our lives. Good point, Pete.
Yeah, hi, Bill Bonfleth, Penn State Architectural Engineering. Rich showed some interesting data on effects of temperature and humidity on air quality, and it raises 2 interesting questions for anybody who is involved in design and operation of buildings. First one is, where do you come down on temperature and humidity from the point of view of set points if there's now an impact on air quality, and at the same time it's coupled to the thermal comfort of the space, which actually, if you look at Bill Fisk's research on the cost of poor indoor environmental quality, thermal environment is more costly than air quality, given the way we maintain buildings. So is anybody looking at these interactions and the implications for the cost of running a building based on what science is starting to tell us?
I think Michael Waring at Drexel has recently published a paper, or is in the process of doing that, of showing that linkage.
You mean like between ventilation and economics?
Yes.
I was on the committee of his 2 doctoral students who did that work. So yeah, it's related, but I think we have a ways to go.
So my last slide, which I didn't get to go through, there was, you know, one of the bullets for future work is not only understanding the health impacts and the productivity impacts, but also the economic impacts of indoor chemistry and environmental conditions. How we define environmental conditions with thermostat settings, set points, et cetera, is important, and we really need more research in that area. I think if this field progresses, one of the things that will help it progress is understanding the costs of not doing anything, right? So I think it's an area that needs a lot more research, Bill, and it's a great point.
I have another short one for Alan while I'm here. You sure they weren't just making a lot of toast instead of drinking at that party? But I was interested in the fact that you really didn't see any difference between winter and summer. And you made the comment that the airflow was from the bottom through the top. And if you had a climate where there really was a winter and a summer and you didn't have a pressurized building, you'd expect the stack effect to reverse between winter and summer. Why do you think that was?
It's interesting. The stack effect didn't reverse between winter and summer. And where this building was, it does get to below freezing temperatures in winter, probably 20 nights a year, and it certainly happened during our study. But I only had 14 minutes, although I think I took a few more. There's some more detail that I could have told you.
With this question.
It's terrible being a moderator.
One of the things I want to say is what I showed is the concentration winter versus summer on a log scale. So there's a lot of room for slight differences, but the main point that I want to make is the emissions in the winter were actually about half of the emissions in the summer. The emissions in the summer were twice as high, but the ventilation rate of the building was twice as high in summer. So we ended up with the same rough average concentrations winter and summer, but it's because both the ventilation and the emission rates changed between winter and summer. So that's maybe a subtlety that's of interest to people who are into the processes, but in terms of what people were exposed to, it was similar in winter and summer for the most part.
Thanks, that helps.
Okay.
I'll get the last question from a write-in question. Similar to emissions of greenhouse gases dominated by fossil fuel combustion, do you think a similar analysis for indoor VOCs would lead to fossil fuel origin as products of combustion or byproducts as well? Shall I read? I'll read the question again. You want me to read again?
Sure.
Okay. Similar to emissions of greenhouse gases dominated by fossil fuel combustion, do you think a similar analysis for indoor VOCs would lead to fossil fuel origin as products of combustion or byproducts as well?
Well, okay, a couple of comments at the risk of going first. One source of indoor chemicals, particularly NOx, is burning fossil fuel. It's cooking, right? So there is importance of using fossil fuels indoors, but also a lot of consumer products are made from petroleum, petrochemical, and there was actually a really interesting paper in Science last year by Brian McDonald that focused on consumer product that were made from petrochemicals and how much emissions from those petrochemicals went to the outdoors. In the indoors, I think there are sources like that, but they're not the only sources. There are lots of other sources, and in most cases, I think they're probably not the dominant sources. But they exist, and in certain kinds of indoor environments, you may have a lot of those. But they're from consumer products that people bring into their homes.
Okay, so in the interest of time, we'll close this session. I'd like to thank all the speakers.